So far we've learned the basic parts of a polynomial function equation. Now we're moving into that part of this lesson where we are going to learn important information about the graph look of a certain function just by looking at the equation. So we have three main things that we're going to watch for, and it's exactly the same things we've talked about in the previous example. So the degree of the polynomial function, it will tell us three pieces of information. It will tell us how the shape of the graph looks like, how many x-intercepts possible a graph can have, and how many turning points I can expect for a certain graph. And the second piece that we take from the equation, that is the y-intercept, the free terms. The free term, the term that has no x, it will tell me where the actual position, the actual point, the y-intercept of that function. And the last thing, the sign of the leading coefficient. Only the sign, not the actual value, because we're not going into that much detail. Only the sign will tell me a bit more detail about the graph, not only the shape of the graph, but how is it oriented. Is it going up or is it coming down like that? But I want you to stay away from words like increasing and decreasing, except for the linear function, polynomial of degree 1. Only for those functions you can use the words increasing and decreasing, and actually a little bit for the cubic function as well. Okay, why? Because the word increasing, if you refer to the entire function, is only used if the entire function is always increasing. If your function is undulating, so it's increasing on a certain portion and then comes back down, then it's not entirely increasing, so you cannot use that word. Okay. You can use an increasing trend, overall trend. So I'm going to be watching for those details to see that you understand the idea of an increasing or decreasing function. So let's start with the degree of the function. So what is the information that that part of the equation tell us? And then we're going to move on to the other parts. Here, under the degree of each of these types of function we're going to talk about, so degree 1, 2, 3, these are only the types that we're going to talk about in this lesson and in this course. I also put down those common names for these polynomial functions. So the degree 1 polynomial function is easier, like as a common name, it's called the linear function. So if somebody says, I am taking this linear function, it's already implied it's a polynomial function. We have degree 2, this type of function is called quadratic, and degree 3 is called cubic. And we have other names for the next two as well. If you're going to take pre-calculus, you're going to learn those ones as well. So first, we're going to take degree 1, and I've made a little bit of a copy of this page on a piece of blank paper. I'm just going to make it a little bit nicer looking here for you. Okay, so we're starting with the first table there. The degree will give you information about. Okay, and the first piece of information you can take from the degree of the function is the shape of the graph. Okay, now the top of this table, it's an equation characteristic, because the degree of the function, it comes from the equation. So equation characteristic. And here, when I'm going to fill it out with information about the graph, that's a graph characteristics. Graph characteristics. This is really difficult sometimes for students to differentiate between them too. But you have to just think about it. Is it coming from the equation, or is it looking into the graph when you're talking about that piece? Or is it a part of the graph? Okay, so for the degree 1, for a linear function, the shape of the graph is a line. Okay, so I'm just going to do a line. Okay, now if you want, you can put the x and y axis in it. Maybe I'll do that too for all of them. Okay, so That's the first one. It doesn't necessarily have to have only this orientation. We're just talking here about the shape. If I'm talking about the linear function, I can already picture it in my mind that the graph is going to be a straight line. The way it's oriented, the way it has a slope, that's a little bit different, okay? But this piece of information, the degree, is telling me the shape of it. Now for a quadratic function or a polynomial of degree 2, we have parabola shape. So it's going to look like that. This is a parabola up, but I can also have parabola downwards. And then for the degree 3, I have what I call the snake graph. So it looks like that. And here in the middle, that portion can be a bit more accentuated. It doesn't have to be so lean in an increasing shape here. So it can actually be like that. Okay, so it has to have more of an up and down hill and valley. So this is a line. That's really what I picture in my mind. This shape, it's called a parabola. And this one doesn't really have a name. I call it the snake graph. So you can put that down if you want, but it's not an official name for this shape. It's just an undulating graph. It's a continuous curve, you know, with hills and valleys, starting with the degree 3. All of these polynomial functions will basically look like this, with just more hills and valleys in between, or like this with more hills and valleys. So that's the first piece of information we get from the degree, the shape of the graph. The next piece of information that we can take from the degree is the number of x-intercepts. A quick reminder, an x-intercept is a point where the graph crosses the x-axis. So let's take it one by one. Again, at the top I'm going to put the graph characteristics, and so far we only talk about the degree. So we have degree 1, 2, and 3. That's going to be the equation characteristics. Did I say graph? I don't know. So the top is the equation characteristics, and here in the bottom, I'm going to put what is that going to give me about the graph of the function. And in this case, we're talking about the x-intercept. The x-intercept is a special point on the graph. So that's why it's a graph characteristic. Let's graph the Cartesian planes really quickly there in the boxes. And now, if I graph a line, and this is just an example, how many times possible can that line cross the x-axis? It can cross once. If it's one of these lines, a horizontal line like that, it's actually 0, right? So it doesn't cross at all. Okay? This is a special kind of a linear function. It's called a constant function. So we say that it has up to 1 time, so it can only cross 1 time, okay? 1 x-intercept. And it's 1 possible, it can actually be 0 as well. So it's up to the number of possible x-intercepts. It doesn't tell you where that is, just how many you can expect, okay? Or quadratic can have up to 2. So it's always the number of the degree, okay? It's up to that number that you can get the x-intercept. So here are some possible drawings of a parabola. I'm going to use only parabolas up. So I can have one like that. I can have one that touches the x-axis. And I can have one that crosses the x-axis in 2 spots. This one has 0 x-intercepts. This one has 1 x-intercept. And this one has 2. So you can see that depending on the parabola that you get from that equation, you can get up to 2 x-intercepts. But you don't know exactly how many until you graph it. But you can expect this possibility. So up to 2 x-intercepts. And a cubic function can get either 1 or 2 or 3. So again, when you're drawing it, that is 1 and 2 right there. There's one possibility like that, only one. And then you can get another one where it crosses 3 times. So 1, 2, 3. 1, 2, 3. Okay? So up to 3 x-intercepts. The last thing we're going to take from the degree of the function is the number of possible turning points. I'm not going to draw again, okay? We're just going to use these examples over here. How many times a linear function changes direction? None, okay? So for a linear function, degree 1, we have no turning points possible, okay? 0 turning points possible. So 0, no turning points. Now for the degree 2, how many times a parabola changes direction? Well, look at it. For this one, for this parabola up, it's decreasing all the way down to the vertex, and then it starts increasing. That's how we define a turning point. A point where the graph changes direction, right? So now you can see it's only one, okay? It has one turning point. And that is the vertex. It's either a maximum or a minimum for parabolas. So you can see now the relationship between the degree. Like if it's degree 1, it's 1 less than that. If it's degree 2, 1 less than that. As opposed to the x-intercept information, it was exactly the same as a degree, right? So the degree tells you exactly the number of possible x-intercepts. And here, the degree tells you 1 less the number of possible turning points. And for 3 is, you want to say 2, right? 2 turning points. But it's actually 0 or 2. Okay, actually 0 or 2, because either I have a function, a cubic function that looks like that, and even though it has some sort of a change here, but it's not really a change in direction. It doesn't come here down enough to be going downwards or decreasing. So it's kind of going to the right and then come back up again, right? So here there's no turning point. And then you can have a shape like that, and that switches straight up to 2 turning points. So you can either have this case or that case, okay? Up to 2 turning points is fine for me, okay? This is a bit more advanced for later on in your mathematical studies. The next part is the free term, okay? So the free term of the polynomial function, and I have here on this page, I'm going to take this down for a second. Can I take it up? The free term, it's better to just talk about it from your notes here, because I have it as an example. So you have this polynomial function. It's linear, 0.5x minus 7. The minus 7 is the free term. So the free term tells you exactly where your graph crosses the y-axis. It's at the point 0, -7. And that is the point form of writing that y-intercept. Okay? And then the last piece of information is coming from the sign of the leading coefficient. And the sign of the leading coefficient, it will complete the graph for us. In the first part, when I started this, I've given you only the positive orientations of all of the graphs. So if you have a linear function, the orientation is going to be like that, an increasing line from quadrant 3 to quadrant 1. So let me just add that in. I'm not going to finish this, so I'm going to continue on in the next video.